Welcome. Let's solve Leetcode 494 target sum. Okay, so let's read the problem. You are given an integer array nums and an integer target. You want to build an expression out of nums by adding one of the symbols plus or minus before each integer nums and then concatenate all the integers. For example, if nums equals 2, 1, you can add a plus before the 2 and a negative before the 1 and concatenate them to build the expression plus 2 minus 1. Return the number of different expressions that you can build which evaluate to target. Okay, I think that's a little bit misleading in some manner, but we can go with it anyway. So let's use this example. We're given this nums array or list, and it all consists of all the values 1, 5 of them in fact, and target is 3. So we want to know if we can make some combination of these positive and negative such that the result after summing them is 3. So here they give us all of the possible solutions, and here they add a -1 and negative to the first value or the first element, and the rest of the elements remain in essence they remain unchanged because they're positive and these are positive. So this gives us 3, and what we can do is just switch the value for each of them, for each element along this diagonal, and or basically apply the negative to each one of them individually, where the remaining values stay the same. In that case, when we sum them, the result will always be 3. So in this case, there are 5 solutions. And in this case here, for this example, there's only one way to reach 1 with this one element. Okay, let's go over a couple constraints I think that are important to know. The values will always be positive according to this constraint here. That's something interesting to know. So I thought we should at least mention that. Okay, so I'm going to go over 2 solutions, one involving recursion and another one involving dynamic programming. The dynamic programming will be somewhat more optimized or in terms of time complexity. So I wanted to make sure I point both of them out. The first solution I'll go over is we'll use recursion, because for me that seemed more natural, and so that's why I went with it first. And it's a little bit slower, and that's fine. It's still quality, but the second solution will be a little bit quicker, or much quicker, maybe even 5 times quicker. So in any case, let's get started. Let's move this out of the way. So I've written an example here. So 1, 2, 1, and 3, and the target is 5. So what we're going to do is we're going to start at every index, and we're going to, all right, so let's write that down. We will start at stop at every index, stop at every index, and ask ourselves, use it or not, or not to use it, not to use it. So we're going to use it or not use it, and that's basically the entire problem right there. And as we use it or not use it, we'll adjust our goal. As we traverse every number, we will adjust our target. We will adjust I'll just say our goal. So the goal here is to figure out at the end if we can reach a value of 5. Remember that we have to reach the end. We can't say somewhere in the middle. We have to reach the very, very end. And if at the very end, if our goal is in agreement with this target, then we're good to go. So let's start here with this first index. So index 0. So the number is 1. However, though, we can make it a 1 or a negative 1 according to the rules. They tell us that we can put a plus or minus in front of it. Okay. So remember, the goal is we want to end up with 5. So our current total would be, we'd have two totals. We'd have 1 or negative 1 because we have 1 or negative 1. But we're only at index 0, so we need to move all the way to the end. So, okay, this is where we stand. The next index, the number is 2, so we can make it a 2 or a negative 2. Okay, no problem. Now, we can apply this positive 2 to each of these so that we have, okay, then this would become, so this 2 plus either of these would become 3, or 2 and negative 1 is positive 1. Or we can apply this negative 2 to either of these again. So then we'd get negative 2 plus 1 is negative 1. Negative 2 plus negative 1 is negative 3. So these are our totals after index 1. Okay, moving on. Let me make this a little bit bigger. Moving on. So index 2. The number at index 2 is 1. So that means we can use it as a 1 or a negative 1. So now we have to apply this 1. Let's apply this 1 to all of these. So 1 plus 3 is 4. 1 plus 1 is 2. 1 and negative 1 is 0. 1 and negative 3 is negative 2. Okay? Now let's apply the negative 1 to all of these. Negative 1 plus 3 is 2. Negative 1 and negative 1 is negative 2. Sorry, did I miss one? Sorry. Negative 1 and 3 is 2. Negative 1 and 1 is 0. Sorry. Negative 1 and negative 1 is negative 2. And negative 1 and negative 3 is negative 4. Okay? And we're almost done. Now we're at the last value. Index 3. So we have a 3. Or we can use it as negative 3. So then we check. Okay, we're no problem. So apply 3 to all of these. That's going to be a lot. And in any case, we get 7, 5. 3 plus 0 is 3. 3 and negative 2 is 1. 3 and 2 is 5. 3 and 0 is 3. 3 and negative 2 is 1. 3 and negative 4 is negative 1. Now apply the negative 3 here. Negative 3 plus 4 is 1. Negative 3 and 2 is negative 1. This is negative 3. Negative 5. Negative 3 and 2 is negative 1. Negative 3 and 0 is negative 3. Negative 3 and negative 2 is negative 5. And negative 7. Okay, so then we ask ourselves, okay, we're done. How many of these give us 5? Remember, our target is 5, so the answer is 2. And that's, so again, that's it. So answer is 2. Because there's 2 5s. There's 1 here and 1 here. And that's basically the problem. Okay, so I think that's enough to get started. So let's begin. Okay, so we'll want to use recursion. So we'll say, maybe we'll just call it define. I don't know. We'll call it I can't think of a good name, so I'm just call it. I don't know. I'll just call it F. I couldn't think of a good name. And so remember, we start at the index, and we want to keep track of the value that the goal that we're trying to reach. So we want to reach. Actually, yeah. Do we need to do that? Yeah, we do. We want to reach our goal. So, or sorry, we want to pass in where we're at. So this is how much remaining. So I'll put a little comment here. Current index and not remaining. Let me see. I guess the current total and the current total. Or actually, just do index and total. Maybe that's better. Index and total. For each recursive call, this is going to be I will be the index and R will be the total we have, the current total. Maybe we just call it, yeah, it's fine, R for total. Okay, and then we say, okay, so let's set up our recursive case, or our base case. So if I equals the length of nums, then, well, what do we want to know? That means we reached the end. We've reached the end. So we want to know if this value, if this total equals our target. So, okay, so then we say return R equals target. Okay, great. That's our base case. Next, let's perform our work. So we say, so we want to use, let's suppose we use the positive of the value. So what's the positive of the value? The positive of the value is nums I. This is the positive of the value. And that means whatever the total is currently plus this new value. So yes, sorry, is that right? Yes. So let me write that again. So whatever the starting value is, or whatever this is, we're adding nums I to it. And then we're moving on to the next index, I plus 1. So let's go over what this means. We're saying we're going to use the current number, which is right here. The current number, like we did here. Remember we said the current number plus the other guys, whatever that is. And this is the other guys. That's what this is. So the current number plus the current total, and then move on to the next index. Or we still want to move on to the next index, but we're going to say R minus nums I. So for example, if this is 0 here, so numbers of 0 would be 1, or the negative of that, -1. So that's what we've done here. And all we need to do is just return that, whatever that is. Return that. Okay, so if you notice, so I'm going to submit this now, but it'll be too slow. So we're going to start off at index 0, and our current total is 0. We have nothing available. So let's run that locally, and let's see what happens. So it'll probably be, we might get the right answer, but when we submit it, it'll be too slow. So what we'll end up doing is adding caching to the solution. Let's submit it. Yes, so it's, just as I mentioned, it's too slow. So let's try it again, or let's add caching to it. I apologize, I don't know what's going on here. Okay, let's try it again. And there we go. This works perfectly fine. So this was our first solution using recursion. Okay, so let's try another approach now. Okay, so let's erase all of this. We don't need it. So this is going to be pretty interesting. Okay, so let's start. What I'm going to do is I'm going to set s equal to the sum. I'm going to change these variables, sorry, n and t. So I'm going to set s equal to the sum of n. Okay. And so let's go over a quick example like I had earlier. So let's say nums, let's set numbers equals to, what is it? 1, 2, 1, 1, 2, 1, 3. That's just it. And the target is 4. Target is, what was it, 5? Sure. Okay, so let's go over something really quickly. The sum of numbers gives us, what is it, 5, 6, 7. Now let's think of something real quick. Suppose the sum was this here. Suppose the sum was this. The numbers was this. 4. and the target is 5. So some of the numbers is 4. Notice how we could never reach, with all of these numbers, if they're positive, there's no way we could ever reach 5. So that's something that we want to check. So if the sum, if the sum is less than the target, we want to return 0. I hope that makes sense. Return 0. Now we do have one more also slight consideration, or a slight, not slight, but an important thing to consider. Now here we go. Suppose now let's make this 3 here, and let's make this, so what is this, 5, 6, 7, and let's call this 7, maybe let's call this 4. Yes, let's call it 4. Okay, great. Now the sum of the numbers here is going to be 3, 5, 6, 7. 5, 6, 7. Sorry, let me take this back because I need to change this. Let's make it 10. Target. No, I was right. My goal is to make the target smaller than numbers. That's fine. So let's make it 4. Okay. So now, in this case, the target is smaller than numbers. So that means we could make this value. We could make a 4. We could use 1 and 3. We can make 4. All right. So let's think about something right here. The truth is, it doesn't matter what the numbers are. What we're more concerned is the remainder. So let's think about that. So if I have the sum of numbers, I need 7. We need 7. We need 4. So out of these 7, I need 4 of them. So we need 4 of, or we need target of the sum of numbers. So in this case, we need 4 of 7, which leaves us what? Which leaves us 3. So that means we have 3. So however you want to compose 3, so either it could be 1, 1, and 1, or 1 and 2. However you want to compose them, however it looks, or even just a 3. So we have 3, right? Because we've used 4 of the 7. We have 3 left. The question is, can either of these make 0? So can either of these make 0? Now this is the important question, because remember, we already have 4 of the 7. That's exactly what we want. So we need the other stuff to not affect this, to not mess with it. So that means it has to be 0. So that means we need to apply some negative somewhere. So if you notice the first one, if I add a -1 here, that's not going to give me 0. That's going to give me only 1. If I add a -1 here, that gives me a -1. So that doesn't work. And same thing over here. If I apply the -1 here, that only gives me a +1. If I apply it here, I get a -1. And this is a 3 or a -3. So my point to you is this. If the sum minus the target is odd, then that's not going to help us. So remember, yes, here the sum of numbers was 7 and the target was 4. 7 minus 4 is 3. Is 3 odd? Yes, it is. So it's not going to work. So this is the most important part. When you have a sum and the target, their difference has to be even. If it's not, there's no solution. If you don't understand that, I encourage you to explore it more on your own, or you can just put a comment and I'll make a separate video on that. Okay. In any case, so this has reduced our problem tremendously. Well, let me show you why. So now let's think about this. So remember previously our problem was 4. What I'm saying now, we can reduce the problem. So let's make it here. Let's do this here. So I'm going to say our new target equals s minus t, and I'm going to divide it by 2. Or I'm just going to shift it by 1. This is the same as divided by 2. Divide, yeah, it's the same as divided by 2. Same, I'll just show you. T equals s minus t divided by 2. It's the same as this. They're equivalent. But I just like this because sometimes bit manipulation is a little bit more efficient. Okay, so now what does this mean here? So previously we were looking for 4, but now we're asking if we use this approach. Well, sorry, this didn't have a solution, right? So let me change it up. So our previous example is 5. So this does have a solution because this is 7 and this is 5, and 7 minus 5 is 2. So so that's even. So we have a solution. So then the question becomes, in this case, let me just change this a little bit more. I want to make this a 9. I want to make this a 9. I'm going to put a 4 here. So in this case, so we'd have a 9 and a 5. So that means we would, a 9, we need 4 of, we need 5 of 9, which means we need to find 4. And we could find 4, right? Because if we had 4, we could have, 1, 1, 1, and 1, or 2 and 2, or however you want to make it up, or even 3 and 1, 1 and 3, however it is. I mean, we could make 0. Maybe not all of them work, but we could find a 0. Like, for example, we could do a -1 here and a -1 here, or a -2 and a +2. It doesn't matter. This one doesn't work, but it doesn't matter. My point is, we could still find a solution. We could still find one. On the other example, we couldn't. In any case, I wanted to point something out to you. So we need to. Our target is 4, right? That was what we were left with. But we can reduce it even more because we only need to find 2. I mean, half of that. Because remember, the other half will be negative. So if we can find half of it, however many ways we find half of it, we're good to go, because the other half will just be the negative of that. So I hope that makes sense. So that's why we divide this by 2 here. So what does that mean? So if we divide this by 2, that means we only need to find a new target of 2. So remember, our original target was 5. The sum was 9. 9 minus 5 is 4. And now we divide it by 2, so we get 2. So notice how this reduces our problem, because originally we were trying to find 5. Now we're only trying to find 2. So it's a little bit smaller. So that kind of affects our answer. It's that makes the amount of work we have to do a little bit less. Okay, so now let's move on. So what I'm going to do here is we're going to use a default dict. So we're going to say, okay, so we're just going to call it dp equals default dict, and it's going to be int. And we're going to start it off with dp of 0 equals 1. Now what does this represent? This says the number of ways to make 0 is 1. That's what this says. So eventually, though, we'll want to ask return dp of t, number of ways to make t. Remember, this is our new target here. We've adjusted it. So eventually we want to return this. Okay, so let's move forward. So now for every number in n, just like before in our previous solution, where we needed to check every value, we want to do the same thing here. So what we're going to do is we're going to say, okay, for the next iteration, so remember for the previous example, we started with index 0 and 1 and 2. Same thing here. We're going to kind of do the same thing here. So we're going to make a copy of, I don't know if you remember though, over here we had the numbers, and then we had some values. Here was, I don't know what it was. It was, 2 and -2. And then remember, we had some values over here that were the previous totals. Then we added the totals here. We said, okay, 2 plus 1 is 3, and then 2 plus 1 is 1, and then whatever dot dot dot. We're kind of going to do the same thing over here. We're going to say, okay, next equals. We want to modify this because we're going to be adding counts to it. So we're going to say, okay, dp.copy. We're going to make a copy of it. Okay, so let's move forward. So for kv in dp.items. So originally, there's only one, right? There's just this here. It looks something like this. Okay, so then we'd have, we're going to check if this number plus this number is less than or equal to our new target. So let's check it out. So if the number in the current dictionary, and this is the number that we're interested in, so which in our case would be the 1 here. So we want to say, okay, is 1 plus 0 if k plus n less than or equal to the target? If it is, we adjust our memo, our record of number of results to get there. So next of k plus n plus equals v. So what does this mean? All right, I'll just show you the next level. And then we'll say, okay, in that case, we say dp equals next. So let's just print it out here. What we'll do is we'll say, okay, let's print out k. Let's print this out. Let's print let's print next. Let's print n, and we'll print next. And then in this case, do we need to print anything? I think that should be fine. And then at the end, we'll print out the new dictionary. So we'll print next. And let's print it out just to see what it looks like, so we get a better understanding of how we're moving along. If s is less than 2, no, sorry. Okay, so we know that's working, so let's check what's going on here. So I'm actually going to make a new example because I don't think this example is good, the 1 1 1 1. So let's maybe make a new one. So let's maybe use 3 1 and 2 and 1. Okay, let's do that. And the target will be, we'll just say, so that, what is that, 5 6 7, and which should, I think, yeah, 3 is okay. Actually, let's make it 5, how it was before. Okay, so let's run this then. Okay, so let's check what's going on here. So we start off with, oh, the wrong example. Okay, so we start off with this 3. Let's go back to the code here. You can see it. So we start off with the number 3. That's the first value, and we initialize our not our dictionary, but our history, the previous results. So this says there's one way to make 0. Now we want to say, okay, now we have a 3. So we're asking, oh, sorry, one thing we should print is our new target. Sorry. Print new target. Remember, we adjusted it, so we adjusted it here. So our new target, the new target is 1. If you recall, so the new target is 1 because if we look at these numbers, so this is 3 and 5, 6, 7, and 7 minus 5 is 2. So that means we need to account for 2 of the values, and then we can divide that by 2. So we need only 1, really. So if we use the 3 here, if we use 3, we can't make 1. So that's why it doesn't change our history, our current counts. Now the next value is 1. So then that works. So then we say, okay, because we see if the current number, which is 1, that's what this is. So this current number, this n is this 1 here. And then we check for everything in the current state so far, or the history. Currently in the history is 0, 1, is this here. So we're saying is 0 plus 1 less than or equal to 1? Yes, it is. So then we update next to have next of 1 plus equals whatever the count is. And there's nothing there. There is 1 isn't in our dictionary here, so then we add 1 to it. Then we go on to the next one. Next one is 2. 2, we check if we have 2 to what's already there. So 2 plus k, so k is this. 2 plus 0, these are our previous history, is 2 plus 0 less than or equal to 1, which is our target, our new target. That isn't there. All right, it's too big, so it's not going to work. Is 2 plus 1 less than or equal to target? No, it's not. So it doesn't affect our history. So we can't use it. Moving on, we have this last one here. Okay, so this last one says, okay, u. If I add u to one of these as 1 plus 0, will that be less than or equal to 1? Yes, it is. So it says, I'll add you to what was ever there. Sorry, it didn't print it out. Let's print out. Oh, here it is, view more. Sorry. It is here, sorry. So this 1 and this 0, it said, yes, this is less than or equal to 1, so it adds it here. So it says 1 and it adds it there. And then 1 plus 1 is 2. Remember, this is it. So the current value is 1, and we want to compare it with this one, add it to it. Can we use it? So no, we can't. So we don't apply it. We don't apply it. So at the end of the problem, we simply return dp of 1, and which is 2, and that's our answer. So I hope that makes sense. Let's remove these print statements. Most people use an array or a list to store it, but this is perfectly fine as well. I think that's it. Let's try submitting it. Oh, what went wrong here? Let's see what happened here. T is greater than, oh, sorry. There should be an or up here, sorry. Okay, so as you can see, it's significantly quicker using this approach than the dynamic programming approach. So the recursive approach is slower than this approach, and because we don't need we kind of reduced our problem tremendously by going this route. Okay, so if you found this in any way helpful or beneficial, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.